Hello and welcome to the notes for Unit 3. This is going to be 3.1 day A, or day 1. All right, so today we're going to start looking at quadratic functions and how to graph them. So the first thing we're going to talk about is what a quadratic function is. Well, a quadratic function is a second degree polynomial. Second degree just means that the highest exponent is 2, whose graph is, it forms what we call a parabola. All right, so it's not technically a U shape, which we always call it a U shape. It's not technically a U. We call that a parabola is the correct term. All right, and so standard form of a quadratic is ax squared plus bx plus c, where a cannot be 0, and a, b, and c are integers, which means they are whole numbers. They can be positive or negative, but our a is always positive. Or at least we want to make it positive. All right, so the first thing we're going to do to graph a quadratic is we're going to label the axis of symmetry. Now, every parabola has an axis of symmetry. It's that imaginary line that can cut the graph in half. So you can imagine that in every parabola, so every parabola has a line that you can fold it over. That would reflect from one side to the other. They would be like a mirror image of each other. So our axis of symmetry here in this graph, this first graph here on the left, is this imaginary line that is green here in my notes. So that is our axis of symmetry. Our y-intercept is where our parabola crosses the y-axis, and that would, of course, be the red dot. The x-intercepts are where the parabola crosses the x-axis, so that would be the black dots here. And there are 2 of them on this left one. And then our vertex is this blue dot. All right, that is there at the bottom. And notice the vertex is on the axis of symmetry. Okay, let's move over to this graph on the right. Okay, the graph on the right here, again, axis of symmetry is this imaginary vertical line that cuts the parabola in half. Our y-intercept, again, is this red dot on the y-axis. The x-intercept is these black dots. And then our vertex, again, is this blue dot that is, again, going to be on the axis of symmetry. Notice that the vertex is always either a maximum point or a minimum point. If the graph opens upwards, it means that as x goes towards negative infinity or positive infinity, the f of x is going up towards infinity. It has the vertex is a minimum point. If the parabola opens downwards, so the end behavior is going down towards negative infinity, the vertex is a maximum point. All right, so if a is greater than 0, the graph opens upward, and the vertex has a minimum value. If a is less than 0, so if our first number, our a, is negative, the parabola is going to open downward, and the vertex has a maximum value. All right. Now, what's cool is that we can always find the axis of symmetry by a very easy way, and that is the equation x equals negative b over 2a. Now, remember, if our equation of a graph is x equals a number, it's going to be a vertical line. And every axis of symmetry is a perfect vertical line. So we take our b from our standard form, our ax squared, just write that again, plus bx plus c, and we take that b and we make it negative, and then we put it over 2a. And that is how we can figure out the equation of our axis of symmetry. So, to graph a quadratic, there's a simple formula. All right, so the first thing we're going to do is find that axis of symmetry and plot it on the graph. So we're just going to take that negative b over 2a, and then once we simplify that as much as we can, we're going to plot that onto our graph. And then remember, that's going to be an imaginary line. All right, then we are going to use that x value and run that through our function, and then that'll help us figure out our vertex. All right, then the next easiest thing to do is to plot our y-intercept. Our y-intercept can always be found as the c in our function in our standard form. So the c is always going to be our y-intercept. And then, of course, we can reflect across our axis of symmetry to plot our y-intercept as well, or the opposite side of our y-intercept, so the reflection of the y-intercept. And then we're going to make a table of values. We can pick a couple of 2 or 3 values for x that are between our axis of symmetry and our y-intercept, hopefully. If not, then we can pick some that are close by that we're easily able to graph. And then we're going to solve for y for each of those. And then, just plot those points. And, you only have to do one side because of the mirror effect with the axis of symmetry. So we can just reflect across that axis to get additional points. Then we just connect the points to get a parabola. And then we want to state the domain and the range lastly. All right, so let's look at an example here. We've got y equals x squared plus 4x plus 3. Well, the first thing I can do is look at this equation and see that my a is positive. So that means that this thing is going to open upwards, and that means our vertex, of course, then would be a minimum. And our a is 1. It's that imaginary 1 that's in front of the x squared. Not imaginary, it's just implied 1. So next, we're going to look for the axis of symmetry. So the way we do that is negative b over 2a. So just put this off to the side here. X equals negative 4 over 2 times our a, which is 1. So that's negative 4 over 2. Negative 4 divided by 2 is the same thing as negative 2. So our axis of symmetry is x equals negative 2. So plot that imaginary line. So we always do it dashed because it's not actually there, it's just implied. All right, then we're going to take that negative 2 and we're going to plug that into our equation. All right, so negative 2 squared plus 4 times negative 2 plus 3. So when I say plug it in, I'm just going to substitute that x value into our equation for every time there's an x. So negative 2 squared is 4. 4 times negative 2 is negative 8. And then now we can simplify. 4 minus 8 is negative 4. Negative 4 plus 3 is negative 1. So our vertex is at that x value of negative 2 and the y value is at negative 1. So we can go ahead and plot that point. All right, the y-intercept is always the c value of our equation. So our c value is 3. So our y-intercept is at 0, 3. And then we can reflect across to get that. All right, so let's make a table. I know that I have points at negative 4, 3. I have a point at negative 2, negative 1. And I have a point at 0, 3. So what I'm missing, of course, would be the negative 3 or the negative 1. All right, and we'll figure out what that is just by going, just plug that in. Negative 3 squared plus 4 times negative 3 plus 3. So negative 3 squared is 9. 4 times negative 3 is negative 12. And then plus 3 there. So 9 minus 12 is negative 3. Negative 3 plus 3 is 0. And then, of course, we would reflect across to get 0 as well. So now I can fill out this parabola. Let's go ahead and run 1 through the function as well, just to 1, and we can figure out then, of course, negative 5. Those would be the same, just so that we can really fill this thing out. So 1 squared plus 4 times 1 plus 3. So 1 squared is 1, 4 times 1 is 4. All right, so 1 times 4 is, or 1 plus 4 is 5, plus 3 is 8. And the mirror effect would say that would be 8 as well. So now we really have a full parabola here that we can really plot. All right, and that'll go up forever that way. So the domain of every single one of these quadratics is going to be negative infinity to positive infinity. All right, so if that's even if that's the only point that you get on the test, please at least get that one right. All right, for the range, what we got to do is look at that minimum value, which is the y value of our vertex, so that'd be negative 1. And it goes up to positive infinity. So that would be our range, all the y values. All right. So, not too bad, right? We can do this. Let's look at example 2 here. Example 2, we look at our a value first to determine if it opens up or down. It's negative, so that means we're going to open down, and that means our vertex will be a maximum point, and our a is negative 1. Now our line of symmetry, axis symmetry, we can figure out by x equals negative b, so negative 3 over 2 times a, which is negative 1. So that's negative 3 over negative 2, which negative divided by negative is a positive, so that's 3 halves. So we'd say x equals 3 halves, and we can go ahead and plot that point, or that line, I should say. And that's going to go through kind of halfway between the 1 and the 2 there. That's 1 1/2, 3 halves. So our vertex, what we're going to do is we're going to plug 3 halves into our function. So negative, and then we do the parentheses, 3 halves squared plus 3 times 3 halves plus 4. So 3 halves squared is going to be 9/4. So that's going to be negative 9/4. 3 times 3 halves is going to be 9 halves. And then we have 4 here. Now, in order to add fractions, we got to have common denominators. So lowest common denominator would be 4. So we got negative 9/4 plus 18 over 4 plus 16 over 4. Just converting all those to have a common denominator so I can add those up. Negative 9 plus 18 is 9, and 9 plus 16 is 25. So we end up with 25/4. All right, so 25/4 is the same thing as 6 1/4. Okay, so our vertex is at 3 halves, comma, 25/4. I know that's not pretty, but welcome to Algebra 2. All right, so we plot that point there at 6 1/4, 25/4. And that's our vertex. Our y-intercept is, of course, going to be at 4, so 0, 4. And we can mirror that. So we would have a point at 3, 0 as well. All right, so we've got some points we can fill in. We've got a x value of 0, and we have a y value of 4 there. We have an x value of 3/2, and we have a y value of 25/4. And then we have an x value of 3 with a y value of 4, sorry. So let's fill in, let's figure out what is going on when x is 1 or 2, and then let's see what happens when x is -1 or 4. Either one of those should give us the same number. All right, so negative of -1 squared plus 3 times -1 plus 4. So that's going to be -1 minus 3 plus 4. -1 minus 3 is -4. -4 plus 4 is 0. So should have plot points there at -1, 0, and 4, 0. And then we can also figure out what's going on with 1. So just plug 1 into our function. 1 squared is 1, so that's -1. 3 times 1 is +3. So that's going to be -1 plus 3, so that's 2 plus 4, so that's 6. Oh, sorry, that should have been there. So we have 1 at 1, 6, or not 5. Plot that to the wrong spot, sorry. So it's actually really close to our vertex. All right, and just to, kind of see what's going on a little further out, let's do 5 or -2. So we'll do 5. 5 squared plus 3 times 5 plus 4. So that's going to be -25 plus 15 plus 4. -25 plus 15 is -10. -10 plus 4 is -6. And then, of course, that would mean we have 1 at -2, -6 as well. All right, so there we go. Now we have our vertex and several points to plot our parabola off of. That opens downward. Of course, our domain is always -infinity to +infinity. Our range is going to start at -infinity, and it's going to go up to that maximum value of 25/4. All right. Lastly, y equals x squared minus 9. Notice there's no b here. First thing, though, let's figure out if it opens up or down. A is positive, so it opens up. That means we have a minimum vertex, and our A is 1. There's no B, so x equals -0 over 2 times 1. Well, that's just 0 over 2, which is still 0. So our line of symmetry is x equals 0. And that's going to be true anytime our B is not there. Anytime our B is not there, our axis symmetry is going to be the y-axis. Zero through the function. So 0 squared is 0. 0 minus 9 is -9. And you'll notice then that's also going to be our y-intercept. So we can't use that for our mirror effect because it's on the vertex. So we got to come up with some more points. We'll run -1, -2, or +1, +2, maybe even -3 or +3 through the function as well to see what's going on. All right, so let's just do that quickly. We'll do 1 squared minus 9. Well, 1 squared is 1. minus 9, so that's going to be negative 8. Oh, plotted that at the wrong spot. We run 2 through the function. 2 squared minus 9, so that's 4 minus 9, so that's negative 5. Both of those are going to be negative 5. And then we could run 3 squared through the function. That's going to be 9 minus 9, so that's 0. And then just to show you 4 squared minus 9, that's going to be 16 minus 9, so that will be 7. So 4, 7, negative 4, 7 there. So we can go ahead and do our best to plot that parabola. All right, there we go. All right. So that is how you graph a quadratic using standard form. So if you have any questions, oh, forgot to mention the domain, of course, would be negative infinity to infinity, and the range starts at negative 9 and goes up to positive infinity. If you have any questions, shoot me an email or a Canvas message, and I'll get back to you as soon as I can. Thanks. Have a great day.